Hi guys, what I have here is a power extension, one of the most popular gadgets we find in our homes and very useful as well. Most of the times it gets bad and the only thing that comes to our mind is throwing it away and then buying a new one. But I can tell us that this does not really get bad. Okay, it does not get bad, it's always fixable. So but the first thing is understanding the connection and understanding how it works. All right, so before you can work on an extension, these are the tools you're going to need. You need a screwdriver like this, you need your digital multimeter, and then you might need a plier. Okay, so it has screw points at the back. It has some screw points. So with my screwdriver, I'm going to unscrew them and then open it to see the internal view of this power extension. Okay guys, this is the internal view. All right, so I'm going to explain all the parts of the power extension one by one. So the first part is the plug. It has the plug and this plug is fused. Okay, so this plug is fused. I'm going to open it now. Let us see the fuse. This is the fuse, guys. What you are seeing inside here is the fuse, and if you watch, here it is written L and here is written N. So this is for live and neutral terminals. So don't mind this arrangement. This fuse does not break the live and neutral. It's just only the live. It is protecting only the live. Okay, so this is how this works. From here, it has a contact with this place. Okay, then from this fuse now, it has a contact with this place. Okay, then from here it joins this red line. Okay, first of all, if you plug here, this is the live. This current comes here, travels to this point, and from here it goes to the red line, while the neutral line is just straight. It is not fused. Okay, so the fuse is just a protective device in case anything goes wrong here. It will just cut internally, and then our gadgets are secure, right? So this is the fuse. So when your socket goes bad, the first thing you are going to check is to confirm that the fuse is okay. All right, to do this, you set your meter to continuity is on continuity. Now I told us that a meter is very necessary in the DIY processes. So we are going to test to confirm if this fuse is okay. One terminal here, one terminal here. Good. So our fuse is okay. So like as I told us, this fuse is not bridging live and neutral. Okay, it's just the live. It's protecting only the live line, right? So that is why we are getting some continuity reading when we test this fuse. All right, so the live and neutral terminals should never read continuity. So as you have checked live and neutral, there is no continuity, so it is in order. So but the live terminal should read continuity with the fuse. Okay, so my probe is still here. I will check the fuse. It must show continuity. As you can see on the meter, it is showing continuity, so it's protecting only this lifeline. If you check the neutral link, there will be no continuity. Okay, so you can see. So we've certified that the fuse is okay, and we've certified that the live and neutral has no contact at all. If it's showing continuity, then it is hazardous, and that would be a problem. So we have certified that the fuse is okay and the live and neutral is not breaching or is not breached. Okay, so the next thing we are going to check is the wire, the cable. All right, the cable travels from this point, it's connecting these terminals to this place. All right, so for us to check the condition of the cable, we are going to test them one after another. So I will put one probe here, then my second probe, this is one probe of my meter, is on the live terminal. Then I will place the second terminal of my probe. The first point, the live wire, is meeting this power extension. This is the live wire and the first point is here. So if I touch here, I should get some continuity. I should get continuity reading on my meter. So let's go, guys. There's no continuity here, so something is wrong. Okay, let us check for this other cable. Let's check the other terminal. Good. Okay, so they used red color for their neutral because we have any here. they use red for their neutral. So this line is true. I hope you can see the multimeter. This line is true. We have continuity reading here. I hope you can see that. Good. Now I'm going to check for the live cable. They use blue as their live. So I have my probe here. We've tested for this place with this terminal. So we check the next terminal with the blue. Now it should also give us continuity reading if everything is in order. Good. So we've now confirmed that the wire is true. It has no internal breakage. The first thing we confirmed is the fuse, that the fuse is in order. The second, we confirmed that there is no breaching of live and neutral. There's no continuity here. The third, we've confirmed that the lines are true to this first point. Okay, so now let's continue. Remember, this is where blue meets the first contact of the blue here. So just watch the arrangement. Once it comes here, it jumps the next. The next is live. Okay, the next is the opposite terminal. Now it comes to the next socket. From this point to this point, we should have continuity. Good. I hope you can see the meter. Good. We have continuity. Then we jump one and we'll come to the next terminal. Good. We have continuity. We'll jump one, we'll come to the next terminal. Good. We have continuity. We jump one, we'll come to the next terminal. We have continuity. So this very line is true. So we do the same thing for the next for the second terminal, which is the red. Sorry. Now if we observe here, the red comes to the switch. Okay, so the red comes to the switch first before they now come to the red terminal. All right, so this is red from supply, is meeting the input to the switch. They used this left terminal of the switch as the input, while the right terminal is the output that loops to the neutral terminal of this extension. Okay, so this is just the connection from here to here, this part of the switch. When you toggle the switch on, it passes current from this terminal to this terminal and it supplies here. Okay, so let me make it a little bolder so we can see what I'm saying. This is the red terminal from the plug. Okay, so it supplies current first to this point. If you press on, it's off. Now if you press on, current will flow from here to here, and from here it comes to this place. So when the switch is on, there should be continuity between this point and this point. So it's another thing we are going to test right now. Okay, so watch the meter. So if I test here and here, I should get continuity. As you can see, continuity reading on my meter. All right, so but if I switch it off, there should be no continuity here. Good, so it is off. So at this point, if you plug this extension, we are not going to get any electricity on this very socket. So let us test this other point. There is no continuity here. There is no okay, there's continuity. Sorry, there's continuity. So let me switch it off and see. No continuity. Let me switch it on. There's continuity, as you can see. So we'll do the same for the next point. There's continuity if you switch off. There's no continuity if you switch on. There's continuity. So let's do it for the rest of the points. So here and here, there's continuity. If you switch it off, there is no continuity. If you turn on, there is continuity here. Okay, so here as well, sorry, at this point we are testing the switches. Now there's continuity, you switch off. There's no continuity, you switch on. There's continuity. So if I put this switch off, all right, this point and its source will not test positive to continuity. So let me show you what I mean. Here and here, we give you no continuity if this switch is off. At the moment it is on. So but if we switch off, we have interrupted the connection between here and here. This switch has interrupted. So if we test for continuity, we are not going to get any reading. Okay, so let's do it. Toggle it on and it will read to test positive to continuity, and if you plug it, you get power here. Okay, so that is just that. We've certified that all the points are in order. Remember, there are certain power extensions where this very switch will have only one central switch. Okay, then from that central switch, it supplies to all the terminals, but this one, all the sockets are controlled by one individual switch. So that is it, guys. The extension is in order. So the only other thing that mostly affects extension is wideness of these ports. Okay, wideness of these ports. Okay, like this one now has completely detached. As you can see, this one has completely detached. This very terminal, it has no contact with this place anymore, right? You can see it. So if you plug this extension now, it's not going to show electricity on this very socket. So what you have to do is to solder this point and this point, and it will start working again. All right, so apart from that, you can see that is looking a bit wide. If you look inward, if you look inside, it's looking a bit wide. So with your screwdriver, you can press it so that it will have a firm contact whenever you plug something from here. All right, so that's the only problem I found with this extension. This place, this very terminal, this very socket will not work. So you just solder it back. If you solder it back, you arrange these terminals, these ports, you arrange it properly, and the extension is in order. So that is it, guys. So no matter the type of extension you meet, just bear in mind that it mostly has a fuse, okay, to control one of the terminals. Then you check these input terminals if they are continuous with, you know, the first meeting point in the extension. So if you test here and here, here and here, and you don't get continuity, just know that your wire is bad. So you can always get, let's say 1 mm or 1.5 mm cable and a plug to replace a bad cable. So just bear in mind that extension can never go bad. Once you have your meter, you can detect what the problem is, fix it, and continue making use of your extension. So but this video is to show us the connection and everything going on in an extension, so that when it gets faulty, we can always find our way around solving problems that may arise from here. So you need your multimeter. It is a very important tool. So if you are testing it from this point, before you would have gone through the whole socket, you must have found out where the problem is, whether it's bad. If it's a bad fuse, there will be no contact between here, between the terminal the fuse is protecting, and the internal terminal here. If the wire is bad, there will be no continuity between these points and these points. If the switch is bad, whether on or off, there will be no continuity between these terminals and their supply. So that is just it. If any of these contacts cut, current will not flow to the socket terminal they are supplying. So with a soldering iron or with a flexible wire, this very one now, I'm going to use a flexible wire to join here, to join this point and this place back, and the socket will start functioning normally again. Okay, so but if the switch is bad, you can either replace the switch or you just join it straight so that it has no on and off again. At every point in time, the particular socket is always supplied. So that is just it, guys. Thanks for watching.